If you remember, in the last module, last lecture, we talked about role of various materials in construction. In this module and of course also in subsequent modules, we shall be talking about the most popular construction material, that is concrete. General outline of this lecture would be something like this. First, we will talk of concrete as a material, and therefore, in this concrete as a material, we should be talking about components of concrete. Well, concrete is a composite. Now, what is composite? I shall define this a little bit later, but for the timing, let us understand concrete as a composite, and that is what we will discuss in this lecture. Concrete has got a wide range of properties these days, and naturally therefore varieties of types of concrete. One of the type is ordinary concrete, which is most popular and most commonly used, and we will then talk about ordinary concrete and its designation. And lastly, we will talk about performance of concrete. Performance of concrete, we shall be discussing about that at the end. So, to start with, we should talk about what is concrete. Now, first of all, let us understand what it is made of. Ordinary concrete is made by mixing inorganic material known as cement and with water, together with some natural sand or stone dust and natural stones that may be crushed or may be uncrushed. This is visible from the figure here. This is visible in the figure here. This is cement, this is sand, and this is stone or coarse aggregate. Cement, when you add with water, it reacts, forming artificial stone like structure, a solid hardened mass, and that is what gives us the cementing property as far as concrete is concerned. But since cement is the costliest of all the materials in case of concrete, therefore, we should restrict its use in concrete. Besides, there are some other associated problem of shrinkage, etc. So, bulk of the material in concrete system is formed by the aggregates, and cements are used as cement and water, or cementing material of the similar kind are used as binder material to bind this skeleton material, that is the aggregates. So, aggregates are binded together by the cement in concrete system. So, that is what is concrete. In other words, it can be said to be an artificial stones made up of stones, sand and a binding material. This common binding material is cement and water. So, components of concrete therefore, cement and water which reacts together and binds the aggregate. The aggregates are nothing but sand and stones. But this is not all. The modern concrete system also uses some sort of admixtures, as we call them, some sort of additional materials, construction chemicals, which when added to the cement system actually improves its property. So, there are other ingredients in addition to these 4 ingredients that I have mentioned. The 2 varieties of those types are, number 1 is chemical admixtures, which could be accelerators. Now, I mentioned that cement reacts with water, forming a stone like material, and when you put also sand and aggregate into it, they bind together this materials to form a system of hardened mass that we call as concrete. Now, cement and water as they react, this is not instantaneous. This prolongs over a very long period of time. Initially, the reaction rate is relatively fast, but then it slows down, but it continues to react over a long period of time. So, I may like to enhance this rate of reaction, and that is what I do using what is called accelerators. The process of cement mixing with water and solidification of the same, we call it setting. That is, when I add cement to water and also maybe sand, aggregate, etc., initially they are in a sort of a semi-liquid form, or I may call it as a plastic form, plastic state. That means if you apply some force, it will deform on its own. Liquid, of course, just if you apply force, they will simply move, simply flow. Plastic is one which will deform. So, plastic is semi-liquid form or semi-solid form, in between the two. So, from this initial state of cement, water, aggregates, their mixture is in plastic state. Then it gradually solidifies into a solid, and that is what we call as setting. So, it sets to a solid. The plastic, cement, water, aggregate mixture sets to a solid, then it starts hardening and finally harden to a strong mass. So, setting, I might use some sort of admixtures to reduce the setting time, reduce the setting characteristics. In other words, increase the setting time, and also might use to reduce the amount of water required to produce a plastic mix. So, there are various types of application. This will become subsequently clear as we discuss properties of concrete or properties of cement and its hydration process. All this will become gradually clear. Now, this is one type of admixture. The second type of admixture is a mineral admixtures. These are some inorganic materials. Many of them are industrial waste like fly ash. Now, fly ash, as you might be knowing, is a material comes out from thermal power plant. We burn coal in thermal power plant, but the coal that is obtained from mines are contaminated with clay materials usually. That is abundant in Mother Earth. So, clay will contaminate most of the mineral, and when we get the clay from the coal from the mines, clay is always present as a contaminant. We grind this coal into fine particles before burning into the thermal power plant, and as we burn, coal that is mostly carbon gets converted into carbon dioxide, but the clay which was there, that forms an ash, remains as ash, mainly of silicon oxide, SiO2 and aluminum oxide. This ash, which are larger in size, they go to the bottom, and the finer ones fly with the flue gas. That is what we call as fly ash, and that is used as a mineral admixtures in case of concrete system. Similarly, there is another byproduct available from silicon industry called condensed silica fume or microsilica. These are also used as mineral admixtures. A third mineral admixtures could be rice husk ash. Rice husk, after husking the rice husk that is left, that can be burned and processed to form what is called rice husk ash. So, all this sort of material can be used as mineral admixtures. This class of materials are mostly silica, and since they can react with lime, forming cement hydrates like product or product of cement's reaction with water, this class of materials are known as pozzolana. Pozzolana, after the name of volcanic ash that is rich in silica and exhibited a property similar to fly ash, silica fume, etc., etc. And these materials in general, this class of materials are called pozzolana, fly ash, silica fume. So, these usually are the major mineral admixtures used in case of concrete. So, what we see in totality, most common of course materials in concrete production would be cement and water together with sand and aggregate system, sand and stones which we call together as aggregate, and then some admixtures which could be chemical admixtures or could be mineral admixtures. So, this forms the ingredients of concrete, right, modern concrete. Well, it may the first cement, water and sand and aggregate, that forms mostly the ordinary concrete, but in modern concretes, even in ordinary concretes, this mineral admixtures are almost an essential part. But in high strength concrete system, they will be definitely present. We will just define what is high strength concrete sometime later on. The most commonly used cement, we call it as Portland cement. It was patented in 1824 in England, and this mixed with water hardens, and since it mixes with water and hardens, we call it hydraulic cement. Now, that means there are other kind of cement also which need not be, or cementing material maybe, which need not use water. So, hydraulic cement is of this kind. How is this material produced? Basic raw materials that are used in the manufacture of cement are calcium carbonate. This is found usually in limestone or chalk, and of course, the other chemical inorganic oxides that go into composition of cement are silica, alumina and iron oxide. These are found in clay or shale. So, what we see is, or you shall see further, is that mainly the material present in cements are oxides of calcium, silicon oxide, aluminum oxide, iron oxide and alkalis, etc. The raw materials, those are limestone and clay, or minerals which are rich in lime and rich in silica and alumina. These materials are burnt together at a temperature of about 1400 degrees centigrade or so to form what is known as clinker, which is nothing but a solid solution of these minerals, forming different cement compounds. We will talk about the cement compounds at an appropriate time, but right now we can understand that cement is manufactured by burning lime and clay together to form into a solid solution, and this product formed is called clinker, which is grinded further and mixed with a little bit of gypsum of the order of around 5% gypsum to control its setting properties. This gives us, when we intergrind clinker and 5% gypsum together, we get what is known as ordinary Portland cement. The name has been derived from a stone called Portlandite that was discovered in the beginning and followed by this formation, like patenting of the cement as a material. Today, of course, you have different varieties of cement, not only the Portland cement with lime and silica burning together and then grinding them with gypsum, but you can also mix materials like fly ash to form or to produce what is called Portland pozzolana cement. This mineral admixtures which I mentioned earlier, they can be added in the production of cement and intergrinded together with the clinker and gypsum to form various types of Portland pozzolana cement. Another material which is also may be used in cement production is the blast furnace slag, a waste product from iron industry. So, cements can be of varieties of kind, which we shall discuss sometime later on. They are mainly produced from lime and silica or clay as raw material, and they can be also mixed with some sort of pozzolana or slag to form varieties of cement. Right. So, this is how we produce cement, and this, when reacts with water or added with water, they react, forming into a hard solid mass, a stone like mass, and that chemically, of course, we call it as cement hydrates, and its various its composition, etc., we shall discuss in appropriate time. The second component in concrete is aggregate, which forms the skeleton. These aggregates are nothing but stone, natural stone, either broken down or crushed to form the right kind of sizes that we require in case of for making concrete, or they can be rounded stones as available naturally, say gravels. So, they are naturally available, but most often we use crushed aggregate depending upon the availability. Since they form the skeleton in concrete, you can see the stones can be seen something like this. This is the part of the stone. So, they are the aggregates. This is the piece of a hardened concrete core taken from a hardened concrete, and we can see this is the stone piece, that is the aggregate, this is the aggregate, even this is the aggregate, this itself is the aggregate, and this aggregate is actually sort of placed or embedded in the mortar matrix, which contains sand and cement. So, mortar matrix is here and this is the coarse aggregate. In fact, the mortar matrix is the large matrix in which these are kind of embedded but closely spaced. Then cement sand mortar again contains sand as the inclusions in a cement paste, cement water that forms into a paste or hardened paste matrix. So, that is what a hardened concrete will look like. This aggregate forms the bulk of the material, that is about 60 to 75% by volume, and 25 to 40% is paste, but still some voids are left, that is about 1 to 2%. The bulk of the material is paste, bulk of the material is aggregate, and that is what imparts major properties. They should be strong. Strength is imparted by aggregate, but it is also important to have good strength between the aggregate and mortar interface, as strength is governed by the weakest link in the system. So, aggregate mortar interface is the one which is important from strength point of view. However, if the aggregate itself is weak, the concrete cannot be strong. So, strength of concrete is important. Also, it should be inert, that means should not react with the environment present and thereby deteriorate with time. It should remain inert from the environment, because after all concrete as a material will be exposed to environment, and there it may come in contact with various aggressive chemicals. For example, a concrete put in a marine environment in sea will come in contact with magnesium sulfate, calcium sulfate, sodium chloride, etc., various other materials. Some of these materials can react with the concrete system. So, and deteriorating in the process, it can deteriorate. So, the aggregate should be such that it is inert, do not react with most of the material present in the surrounding environment. So, the characteristics of the aggregate should be strong and it should be inert. It should be strong as well as inert, should not react with the surrounding material. That is how it should provide, that is how it can provide durable concrete. So, that is the role of aggregate. Now, I mentioned earlier that modern concrete always have some other kind of admixtures together with the basic materials, that is cement and water, sand and the larger stones, which together we call as aggregate. The chemical admixtures are used for enhancing the property of concrete, or sometimes we call it performance. Performance are defined in terms of various properties, how it should perform, functionally perform in when it is exposed during its service condition to environment. When it is exposed to environment during its service condition, how should it perform? So, it depends upon certain properties. So, therefore, we want to enhance certain properties or its performance, we use this chemical admixtures. What are those chemical admixtures? Some of them we will be discussing later on in some of our later lectures. Mineral admixtures, as I mentioned, like fly ash, silica fume, they are used for improvement of long term strength and durability performance. So, historically speaking, when concrete was actually developed as a material and its scientific studies started started being conducted somewhere around beginning or early part of last century, around 1925, the researchers were mostly bothered about its strength properties, strength characteristics, and later on they found that okay, one has to look into its durability properties also. But early 50s, the strength of concrete was fairly low. It was rarely exceeding anything more than 50 megapascal compressive strength. But with the advent of chemical admixtures, this property could be enhanced. Further, mineral admixtures and chemical admixtures together, they opened up the avenues of improving the strength of concrete. And modern high strength concrete or very high strength cement based composites have become possible only due to use of this mineral admixture as well as chemical admixtures. So, using above admixtures together, that is chemical admixtures and mineral admixtures, high strength and high performance concrete materials can be designed. So, what we see therefore, concrete as a material I can obtain at normal ordinary strength or at high strength using various kind of admixtures. Therefore, all this gives us certain advantages of concrete. First of all, ordinary concrete, since it uses stones and major volume of it is actually stones and naturally available sand or crushed stones again, which are naturally available, thereby it is cheap. So, it will have low cost of production first of all. Cement is the costliest materials amongst all of it, but then cement paste, as we have seen, occupies only 25 to about maximum 40% in some special concrete. Rest all is naturally available material, therefore it is cheap to produce. Well, since it is durable, I can make a durable material out of concrete, therefore its maintenance cost also likely to be lower. Putting these two together, the concrete has got a lower life cycle cost, a low initial cost and also low maintenance cost, thereby it has got low life cycle cost. During its life cycle, the cost is relatively low. Then we said that we prepare concrete ourselves by adding cement and water. So, therefore, cement, water and aggregate etc., initially it is in plastic state and I can mold it into any shape. Since I start from the plastic state of the material and I can produce at any place I like, so therefore it is moldable. I can cast into any shape, which may not be possible for many other materials. So, concrete can be cast into any shape of any shape you desire, and that's why it has got moldability. So, this is again another big advantage. I can cast into any shape I like. So, it has got a property of moldability. Now, it has got a property of robustness, which some other materials may not have. The robustness is the property associated with its massivity. For example, a retaining wall, a wall which retains soil, would have a tendency to slide due to soil pressure or might also overturn or topple due to pressure of the soil, or sometime it can happen that in case of a dam, due to water pressure it may slide or topple. Under such a situation, massivity of the structure is very much necessity, and such massive structure can be made of concrete. Therefore, it provides robustness. The robustness is a big advantage for concrete. So, concrete has got lower life cycle cost, it is moldable, it has got robustness, and since I design the material myself, I can change the ingredients, proportion and things like that. Therefore, I can design it for the desirable property, particularly the strength, and its strength today of course is ranges over a very wide range, as we will see in the next slide. So, it has got advantages of lower life cycle cost, moldability, robustness can be available from concrete and can be designed for desired property. There are certain disadvantages, but to overcome these disadvantages, we can add additional material into concrete and make it as required for the desired functional performance. Okay, let us see what are the disadvantages of concrete. Since it is made from particulate system, we are actually putting together aggregates, sand and stones, which are aggregates as I mentioned. So, these are simply particle, and these we are bonding by a cementing material. The most common is the cement and water. So, it is a particulate system bonded by some sort of bonding. Now, this bonding is not usually of the chemical nature, they are of the physical nature, usually due to what is called van der Waals forces. So, these bonds are not very strong to withstand the pull or tensile forces. However, they are very strong in compression or push from two sides. So therefore, it is strong in compression, but its disadvantage is it is weak in tension. Therefore, it has got low tensile strength. Then another property is when we are trying to load, when we load it under high load, when it fails, it does not give much warning. Concrete does not have much capacity to deform, unlike a material, let us say steel, unlike a material like steel. Ductility is a property that is related to its capacity to deform before failure. If it deforms sufficiently, then it will give us a lot of warning prior to failure, and therefore some sort of remedial or some sort of actions can be taken. So ductility is a property which is related to capacity to deform. Concrete does not have this deformation capacity, and therefore it is brittle. So these are the two major disadvantages of concrete, that is, it has got low strength, tensile strength, and low ductility. However, to overcome this, what we do? We reinforce the concrete either with conventional reinforcement. So what we use most commonly is reinforced concrete or pre-stressed concrete. Reinforced concrete is one which gives me both ductility and lower, takes care of the lower tensile strength. So by using reinforcement, most commonly used reinforcement is steel, we can make use of concrete in elements where it requires tensile strength as well as ductility. However, I can also use small discrete randomly oriented fibers to improve the ductility property of the concrete matrix itself, and these are called fiber reinforcement. We will talk about it in the next slide again. So therefore, concrete has got lot of advantages, although it has got some disadvantages, we can take care of it by various means. Thus, it is the most popular construction materials in all over the world today, particularly in country like India. Okay, so this is by and large what I talked about so far is related to ordinary concrete, and I mentioned that I can make a very high strength material out of it, what we call as high strength concrete. However, concrete system today, one can call possibly a cement based composite system today, is very versatile, and you can get very high strength material using this hydraulics cement and water and some sort of aggregate system. So overall concrete can be thought of as a composites today. So that is why concrete and other composites, one may say. This includes materials like normal strength concrete, a high strength or high performance concrete, something called ultra high strength concrete, then something called fiber reinforced concrete, something called densified with small particle, I will just define one by one a little bit, then something called macro defect free matrix, reactive powder concrete, polymer concrete, and polymer cement concrete. So if we see concrete and composite, related composite system today, there are so many classes of material. Normal strength concrete is the one which I have been just talking about, that is, you have cement, water, sand and aggregates giving us strength of the order of about 50 MPa, 60 MPa and not beyond. Then I can enhance the strength of the concrete by using mineral and chemical admixtures beyond 60 MPa, as we shall define, and I can produce what is called high strength concrete system and or high performance concrete by using various kind of admixtures. And then I can make concrete of much higher strength, which I call as ultra high strength concrete. Now, since these materials are all brittle, I can introduce fiber to improve its ductility and resistance, impact resistance against impact, etc., and I get a material called fiber reinforced concrete. So in this material I actually reinforce the concrete with various kind of discrete fiber. Then there are some special class of cement based composites which do not have coarse aggregates, larger aggregates, but usually have cement, sometimes cement with simply another filler material like silica fume, and with some chemical admixtures such as such materials, one of these is called densified with small particles. So, cement you densify with small particles. Then there are something called macro defect free matrix, in which this materials, this set of these three materials densified with small particle, macro defect free matrix, and reactive powder concrete, they are very high strength materials. This material again has got cement and a polymeric material together with materials like silica fume, and they are produced in a given manner to get very high strength material. Reactive powder concrete also uses cement, silica fume most commonly with quartz, and sometimes heat treated autoclave to get very high strength concrete. So, these three are cement based composite, do not have large size aggregate, but the strength is very high. The strength achieved for this in the laboratory is of the order of around 800 MPa compressive strength. So, these are very high end materials, not used for structures very often, but used for mechanical parts or substrate for electronics material, etc. So, these are very high strength material, but kind of cement based composites. So, if we put all them together, these are cement based composites. All this can be said to be cement based composites. In addition to this, I said that hydraulic cement binder concrete is one variety of concrete. Supposing I remove the hydraulic cement and water as a binder and replace it with a polymer, then I get what is known as a polymer concrete. This material is used very much for repair works today, and some cases I remove only part of this cement binder, but use a polymer and also part cement for binding, and this is also a repair material, and this is called polymer cement concrete. So, if I look at concrete and concrete composite system today, that includes normal strength concrete, high strength or high performance concrete, ultra high strength concrete, fiber reinforced concrete, densified with small particle, macro defect free matrix, reactive powder concrete, polymer concrete and polymer cement concrete. So, these are all the materials which can be called as concrete and concrete or cement based composites material. And you can see that strength varies over a wide range, their various properties varies over a wide range, and therefore can be used and designed and used for specific purposes. So, I can express possibly this material I can represent in a 3-dimensional matrix. I can represent this in a 3-dimensional matrix. For example, this axis I can represent a binder, this is binder along this axis, matrix along this axis. So, this is a 3-dimensional representation, and some sort of reinforcement, reinforcement. These are, I am talking of fiber reinforcement here, not the conventional reinforcement. So, binder, so 3-dimensional representation of all this generalized material, cement and cement based composite can be drawn like this. I will have some binder which could be cement and water, OPC, ordinary Portland cement and water, or some pozzolanic cement and water. I mentioned to you what is Portland pozzolana cement and so on, some sort of cement, hydraulic cement and water, that would form binder, or it can be polymer as I mentioned in the previous slide, or polymer cement. So, there can be varieties of binders. The matrix can form simply of aggregates of large stones and small sand, or crushed stones and crushed stone powder as sand. So, there can be various possibilities of using in matrix, or I may not have at all the large size stones, but only have quartz sand, and then some sort of reinforcement. Those are normally of the form of fibers, say steel fibers, polypropylene fibers, carbon fibers, etc. So, there is various possibility, there can be various combination of these binders, matrix and reinforcement forming a material. As an example, let us say take A as a particular cement based composite. It uses this binder number 2, let us say 1, 2, 3, 4, etc., etc. So, it uses binder number 2, uses a matrix, this is again this one, and possibly uses a reinforcement of third kind. So, by making use of different reinforcement, different binders and different matrix, I can get combination of materials. Those are cement based composites. Depending upon the property I need or I desire to have for its functional performance in actual structure, I can choose the binder, matrix and the reinforcement. For example, if I need high ductility, I can choose a reinforcement. If I do not need ductility, I am not really interested, I am getting ductility from some other things, a conventional reinforcement, I may not use a fiber. The matrix could depend upon what type of material is available or what sort of strength I require. For a large, very high strength material, I do not use large size aggregate. Cement binders or polymer binder, they do depend upon usage. For example, for a repair work, I might use a polymer as a binder, polymer concrete, say epoxy concrete. So, epoxy as a binder for repair work, because it will depend upon what is my usage and the performance I require during its service, you know. So, based on this one can select the material, right. So, that is what is a all right. This is what is a material, right. Now, this is so far I have talked about concrete and cement composites. Now, let us come back to our most common material, that is ordinary concrete. In general, concrete, although I have talked about concrete and cement based composites, which have got wide range of properties and wide range of application also. The most commonly used composite, cement based composite is ordinary concrete. This ordinary concrete strength ranges less than 60 MPa, we shall see this later on. But then how do you designate the concrete? All concretes do not have same property, same strength. So, I designate the ordinary concrete by its 28 days standard cube compressive strength. Why 28 days? I mentioned that cement and water reacts, and this reaction is not instantaneous. It prolongs over a long time. By about 28 days, about 90% of the reaction is complete. Most of the strength development takes place by 28 days. So, when concrete material, its scientific background started developing, let us say around 1925, people, the researchers actually, they found that around by about 4 weeks the strength development is 90% of the strength development is complete. So, therefore, for ordinary Portland cement concrete that was most popular at that time, they designated 28 days strength as a 28 days age, strength at 28 days age is a standard at which strength. Now, how do I test such material for their compressive strength? I have to prepare samples. Again, since this it's unlike other materials. So, for example, steel, where you can test a rod for its tensile strength, one has to conceive the kind of sample one would use. So, in Europe, by and large, they adopted cubical samples, and in North America, they adopted cylindrical samples, and they would test it under compressive loading to find out the compressive strength. Since we follow also the European or British practices mostly, therefore, we also in India also we test cubes, and the size of the standard cube in India is 15 centimeter side length. So, 15 by 15 by 15 size cube we test in India, and we designate the strength of concrete by strength of such standard cube. So, we are talking of only compressive strength because concrete is weak in tension. So, we talk of compressive strength of concrete, and we test the concrete cube which we make from the concrete and test at the age of 28 days. So, Indian Standard Code of Practice, I mentioned in one of the earlier lectures that since there are the civil engineering or construction is lot more practice based than purely on scientific or scientific ideas completely. So, therefore, one has to follow codes of practices, and the code of practice that is relevant for concrete is called Indian Standard 456. Its latest version is IS 456 2000. So, there again we define the concrete or designate the concrete by its cube compressive strength at 28 days. The cube has to be cast in a standard manner. So, we pack it or compact it in a standard manner, then we put it or put it in a given condition for 28 days, which we call as curing. Put it in actually water for 28 days at a given temperature, water at a given temperature. So, cured in a standard manner, and then we test it also in a standard manner, so that the variation that we get is because of only the material and not of the test condition or of the curing condition or because of the casting. So, we test them at 28 days, the standard cubes as we call it, and we designate the concrete by what is known as its characteristic cube compressive strength. What is characteristic cube compressive strength? Characteristic means that if I test 100 cubes, 95 of those 100 cubes should show a strength above this value of the strength. So, that strength I take, which will be exceeded by 95 cubes out of 100. Only 5% of the cube can show lower strength. That is what we call as characteristic strength. This will again become clear in our subsequent lecture. So, we designate a concrete by its 95% characteristic cube strength at the age of 28 days. So, when I say a concrete as M25, they are written like this, mixed 25 or M25, M30, M20, etc. So, I designate concrete as M20, M25, M30, etc. or M40, and when I say a concrete is M25, I mean that it 28 days standard cube strength, characteristic standard cube strength is 25 MPa. I repeat, M25 concrete has a 28 day characteristic standard cube strength of 25 MPa. If it is M30, it will have a 28 days characteristic standard cube strength as 30 MPa, and so on. So, that is how we designate ordinary concrete. Right. So, strength is one criteria, and I said normal strength concrete is 60 MPa. So, high strength concrete we define as one which has got 60 to 120 MPa cube strength, and ultra high strength concrete would be greater than 120 MPa. Now, strength is one criteria, but since we make concrete in its plastic state and then it hardens and then it actually its long term properties are also important, it should be durable. Therefore, we talk sometime in terms of performance of concrete. So, performance of concrete in its fresh state. Now, when I say fresh state, what could be the performance? That means how easily it is moldable. If it is very easily moldable, I might say its performance is very good. If it is not so easily moldable, I might say its performance is not as good. However, both have got usage. For example, a concrete which is known as roller compacted concrete may not require any moldability. I might be able to use a lot of energy to mold it. So, its moldability performance may not be, high moldability performance may not be a required thing, because roller compacted concrete is relatively dry and compacted using road rollers. So, I do not require the property of moldability in such kind of concrete. Whereas, there can be another kind of concrete where I may not use any energy to vibrate or compact it. Such kind of concrete we call as self-compacting concrete. This concrete floats on its own and that gets compacted on its own. So, it is called self-compacting concrete. So, performance at the fresh state is also important. Performance at the fresh state is also important, and we can define the performance as we require depending upon its moldability characteristics. Then long term durability performance. In service, concrete may be exposed to a very aggressive environment such as marine environment or environment where it is subjected to sodium sulfate, exposure to sodium sulfate or calcium sulfate, etc., some sort of sulfate which can react with the cement hydrates or product of hydration of cement, or some other conditions where aggregate can react with alkali present in the cement itself. So, there are various kind of reactions possible with the environmental material that is present around the concrete, and it should be able to withstand against deterioration due to such reactions, and that is what is durability of concrete. Its strength increases with time, but chemical agents present in the surrounding can react with concrete and cause its deterioration, and that is what we call as durability. So, various kind of deterioration, various conditions where it can deteriorate are things like sulfate attack, freeze thaw, when it is freezing and thawing of concrete takes place in cold climate or marine environment. So, in such situations concrete may deteriorate with time, and therefore, we might be able to define the performance of concrete in such situation over a long time period. That is what we call as long term durability performance. So, when we talk of performance of concrete, we talk in terms of its strength property, we also talk in terms of its performance during fresh state, during its long term service condition. So, performance is defined in all this. Now, from looking at the concrete as a composites and other cement based concrete or cement based composites overall is a very versatile construction material. It can show a strength from 10 MPa to about 800 MPa in laboratory for reactive powder concrete, but in case of ordinary concrete at least 120 MPa. Just compare all this we are talking of course the compressive strength. We must be it is not very strong in tension, that of course is known to us. Now, one additional thing is that the tensile strength disadvantage you can take care of by reinforcing or pre-stressing it in an appropriate way. So, it can form into a very versatile material showing a wide range of strength properties. We can make it very durable by proper design, and we can get its fresh state performance according to our desire. May require no moldability property or may require very high moldability property as required by our construction of the structure or construction practices. So, it is a very versatile material. This material is very versatile material. So, if I look at then in summary what we have discussed concrete as a material, and we have said that its ingredients are natural aggregates, cement or cementitious. Now, let me highlight cementitious for a moment because I have talked of cement. Cementitious are all other pozzolanas which I have mentioned. So, its ingredients are natural aggregates, cement or cementitious and water, and also we have discussed that there are admixtures into it. Then we have looked into concrete composites, overall composite system, cement based composite and concrete all put together, the whole complete concrete system we have discussed. And then we have also talked about designation of concrete, how we designate the normal strength concrete. And then lastly we talked about performance of concrete in its fresh state, hardened state and hardening state right. So, I think with this concrete as a basic introduction to concrete as a material is complete. Then we can now next look into the process of concrete production, followed by the properties of cement and cement water system and concrete system as a whole, how the strengths develop, how the properties develop, etc., etc. So, thank you very much for hearing, and this completes this particular lecture on concrete material as an introduction.